What is sound? It can come from people, machines, and even Earth itself. But how is it made? It's actually quite simple. Sound is the result of a vibration in an object, which is then dispersed throughout its adjacent medium, usually being air. In other words, a wave of vibration causes particles in the air to collide, and these collisions are what we call sound. The frequency of a wave refers to how often the particles of a medium vibrate when a wave passes through said medium. Therefore, the quicker the particles vibrate when a wave passes through them, the higher the frequency. Now on to pitch. Frequency and pitch are similar, but pitch is merely the human perception of frequency. When a sound has a high or low frequency, we would say it has a high or low pitch, respectively. To sum it up, frequency is how fast the particles vibrate, and pitch is the type of sound we hear from these vibrations. As you can see by the graph, the speed of sound varies in different types of media. On average, sound moves slowest in gases and fastest in solids, with a medium speed in liquids. In sound waves, the vibrations of air molecules travel parallel to the direction of the wave motion and are represented by a sine curve. Spherical waves, however, are all the plane waves of sound being expelled in all three dimensions. To be put simply, plane waves are each individual wave of sound vibration, while spherical waves show the direction that all plane waves travel. The Doppler effect is the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. A way for this to be better said would be that an object emitting sound moving towards an observer has a higher pitch than when it moves away from the observer. As you can see, the waves moving in the direction that the object is moving begin to bunch up, creating a higher frequency, and therefore the sounds of a higher pitch. And the waves moving in the direction opposite of the object's motion begin to spread out, which creates a lower frequency and therefore a lower pitch. Ladies and gentlemen, I will now attempt to calculate intensity and harmonics. Now let's actually get back to something productive. We already know that sound is the result of particles in the air colliding with each other, but the rate at which they collide is referred to as intensity. Intensity and frequency together determine how loud or quiet we perceive sound. If you relate the intensity of a given sound to the intensity at the threshold of hearing, which is the quietest a sound can be while still being audible, you will find the sound's decibel level, or relative intensity. Before we can understand resonance, we'll need to understand natural frequency. Natural frequency is the frequency an object tends to vibrate with when hit. Now that we understand natural frequency, we can understand resonance. Resonance is when an object vibrating at its natural frequency gives off enough vibrations or sound waves to cause another object to vibrate at its natural frequency. When it comes to pipes, there can be two different series of harmonics. A pipe with both ends open will have a series with all harmonics present. With two open ends, an antinode forms at each end, making for a standing wave which includes all harmonics. And the next series is a pipe with only one end open, which will have a series of only odd harmonics. Having only one end open makes a node and an antinode. These will result in a different set of standing waves, which only include odd harmonics. A timbre is the quality of multiple harmonics put together. So, essentially, a timbre is the quality of a song. Two sound waves at different frequencies will produce beats at their points of constructive interference. Depending on the difference between frequencies of the sound waves, this point of constructive interference could take a longer or shorter amount of time. Therefore, the number of beats per second is determined by the difference between the two frequencies.